All right, we are going to talk about what your midterm exam covers in this review. And I created a document here that goes over the concepts that will be covered by the exam, as well as some example problems. So this exam covers the topic of polynomial functions for the most part. Quadratic functions are part of that. They are a type of polynomial. Rational functions, although they are not polynomials, are covered as well in this section because they are made from polynomial functions. So the numerator and the denominator of a rational function are polynomials. And we're also going to be looking at transformations of different types of functions in this midterm exam. So polynomial function has the form f of x equals a(n) x to the n plus a(n minus 1) x to the n minus 1, so on and so forth. And then the last terms are a1x plus a0. So don't be bothered by this notation. We won't use it a lot, but technically this is how you would express a polynomial. Basically, it's just real numbers multiplied by powers of x, added and subtracted together. The degree of a polynomial is n. That's the highest power on x. And the leading coefficient is the real number in front of the x that has that term with the highest power. The domain of a polynomial function is always all real numbers. So that's pretty easy to remember. And a polynomial's degree is at least the number of its x-intercepts. So it might be higher than the number of x-intercepts or equal, but it's never going to be less than the number of x-intercepts. And the x-intercepts are just simply the points on a graph where the polynomial crosses the x-axis. Those are the x-intercepts. The x values of the x-intercepts are zeros of the polynomial function. And a polynomial's degree is at least one more than the number of its turning points. So a turning point is just where the polynomial changes from increasing to decreasing, or vice versa, from decreasing to increasing, where the graph turns back. Then we also are going to cover local and absolute extreme values, or extrema, of polynomial functions, and these occur at the turning points. So like I said, a linear function is a type of polynomial. It's of the form mx plus b, and you can think of this as a1x plus a0. That's another way of thinking of it. Also, constant linear functions are polynomials. So they have degree 0 and leading coefficient b, whereas a linear function in this form has degree 1 and leading coefficient m. A linear function has no turning points, and so it is entirely either increasing, or if it has positive slope, and then decreasing if it has negative slope. And it's neither increasing. If it's neither increasing nor decreasing, it is constant. Quadratic functions are in this form: f of x equals ax squared plus bx plus c. And if you think of it as polynomial notation, this would be a2x squared plus a1x plus a0. But mostly we use this form when we're talking about quadratic functions, because this is the form that we use for a quadratic equation when we're using the quadratic formula, as you can see down here. We have the quadratic formula, and this is the quadratic equation, where ax squared plus bx plus c equals 0. So we'll cover the quadratic formula in this test, know how to solve quadratic equations, know how to find the vertex. And every quadratic function has one extreme value. That's where, the shape of a quadratic function is a parabola, and it opens up if your leading coefficient is positive, and it opens down if your leading coefficient is negative. And there you have the turning point, which occurs at the vertex. The vertex is the turning point. And so the vertex is the location of the extreme value. And with a parabola here in this situation, we would have an absolute minimum, which is also a local minimum, and no absolute maximum. And in this situation, we would have an absolute maximum or local maximum, but no minimum. One thing you should know is the discriminant, that is b squared minus 4ac. It's the part that's under the radical in the quadratic formula. And if the discriminant is greater than 0, the quadratic equation will have 2 solutions. If it's equal to 0, the quadratic equation will have 1 solution. And if it's less than 0, the quadratic equation will have no solutions. Cubic functions have degree 3, at most 3 x-intercepts and at most 2 turning points. Quartic functions have degree 4, at most 4 x-intercepts and at most 3 turning points. And then we are going to cover rational functions, which are this form, p of x divided by q of x, where p of x and q of x are polynomials. And the domain of a rational function is all real numbers except those values which cause the denominator to equal 0. And vertical asymptote is of a rational function are vertical lines, x equal a, where a causes the denominator to equal 0. So whenever we're looking for vertical lines, we always use this formula here, x equal some constant, and that constant causes the denominator to equal 0. To find the vertical asymptote of a rational function, you just set the denominator equal to 0 and solve the resulting equation. And if there are no solutions, then there are no vertical asymptotes. With horizontal asymptotes, it's a little different. You are going to look at the degree of your polynomials and compare them. If the degree of the denominator is greater than the degree of the numerator, then the line, the horizontal line, y equals 0, is your horizontal asymptote. If the degrees of the numerator and denominator are the same, then you would take the leading coefficient m of the numerator and divide it by the leading coefficient n of the denominator. And so y equals m over n is your horizontal line. That's your horizontal asymptote. If the degree of the denominator is less than the degree of the numerator, then there are no horizontal asymptotes. Finally, the test covers transformations, and here are the rules. A vertical shift up is obtained by adding a constant to your function. A vertical shift down is obtained by subtracting a positive constant from your function. Horizontal shifts left, you add a positive constant inside the function. And if you want to shift right, you're going to subtract a positive constant inside the function. So vertical changes happen outside the function, as we see here, and horizontal changes or shifts happen inside the function. Same with reflections. If the negative sign is outside, you're going to go across the x-axis. So that is a vertical change. Everything that was positive is now going to be negative and vice versa. And that's changing across the x-axis, which is a vertical change. Here inside, you have a horizontal change. So everything that was on the right is going to be on the left, and everything that was on the left of the y-axis is going to be on the right. That's reflecting across the y-axis. Then if you have a positive constant where the absolute value is greater than 1, you're going to, well, it doesn't have to be positive. It can be negative as well. But if you have where the absolute value is greater than 1, you're going to have a stretch, a vertical stretch. If it's less than 1, you're going to have a vertical shrink, a flattening of your graph. And similarly, you're going to have a horizontal stretch if your absolute value is greater than 1, and you're going to have a horizontal shrink if your absolute value of that coefficient in front is less than 1. And notice that here the c is multiplied outside the function. That's a vertical change. And if it's multiplied inside the function, you're going to have a horizontal change. So that covers the content of the test. And in the next videos, I'll start doing some sample